Okay, so when a problem asks you to use the 68, 95, 99.7 rule, what they're referring to is the fact that z-scores of plus or minus 1, plus or minus 2, plus or minus 3 correspond to specific points along the bell curve, along the normal distribution curve. And you can use the rule doing a little bit of arithmetic to figure out what percent of data is above, below, or in between two values. So I have a picture here of a normal distribution, and it's got a lot of labels on it. So let me go through what everything is. 68% corresponds to this reddish pinkish region here. So this line is at a z-score or standard score of -1. This line is at a z-score of +1. And when you have a normal distribution, 68% of the data is in between those two z-scores. Now, what that means is that outside, and this isn't explicitly stated in the rule, but what this means is that outside of one one standard deviation is 32%, because 68 subtracted from 100 leaves 32%. So that means 16% of the data is over here, and 16% of the data is over here. So let's say you did a problem and you came up with a z-score of +1, and it said use the standard score to tell how much data is below this value. Well, you'd have 68% in between here and here, and then 16 over here. So that's a total of 68 plus 16, so 84%. So 84% of the data is down here. And if it said how much of the data is above, then it would be 16% of the data is above. So once you've used this rule a lot, these numbers, you just sort of memorize what these numbers are. But in between a z-score of 1 and -1 is 68%. Below a z-score of 1 is 84%. Above a z-score of -1 is also 84%. And then above a z-score of 1 is 16. Below a z-score of -1 is also 16. You can do the exact same analysis when you have a z-score of 2. So the 95% range is the pink plus the purple. And so it extends from this line to this line. This is z of +2. This is z of -2. And that leaves 5% outside of that range. So this green represents 5%, essentially. Well, the green in on to infinity represents 5%. So if it says you have a z-score of 2, or if in the problem you find you have a z-score of 2, and it says what percent of data is below, or what's the relative frequency of data below, that is all of this, which is 95%, plus this. So you end up with 97.5% of the data is below this value. 2.5% is above. And you can do the same thing for a z-score of 3. And then, so 99 point, I didn't write it on here, but 99.7 is between here and here. That leaves 0.3% on either side. So there's only like 0.15% of the data right here and 0.15% of the data over here. But that's how you would approach a problem like this. You can also just use, so this is remembering what the rule is and getting just from this rule what the values are. You can also just look up any z-score in the table and figure it out that way. So I also have the z-score table here. Let me try to center it. Okay, something like that. All right, so we have the z-score table here. So if I look up a z-score of 2, would be right here, we have 97.72% of data is below it. Now using the 68, 95, 99.7 rule, you're sort of rounding the numbers. But 97.72% is from here to here. Now, just using this rule, we would get 97.5, so we'd be off by a little bit compared to what you'd get from the table.